Hi, everyone. We're going to talk about the math behind a Mythbusters episode from many, many years back. Here's the myth. The story goes that, and it's basically from a Hollywood movie, that a bad person is up in an airplane and they shoot a hole in the side of a jumbo jet. And when they shoot this small caliber round through the side of a jumbo jet, that there is this explosive decompression, that stuff, blankets and food and people are kind of sucked out through this tiny little hole. Well, let's do the math and see if it makes any sort of sense. Sometimes Hollywood's good and sometimes Hollywood is silly. So here's the idea. If an airplane actually flies up to 35,000 feet, they adjust the change in pressure from the inside to the outside of the plane so that the change in pressure is about 8 psi, 8 pounds per square inch, as the change from the inside to the outside. Now, as you know, if you've ever been on a big airplane, you go up and your ears are going to pop. You're going to experience some sort of a pressure difference. This is not a fully enclosed can. They're constantly pumping some fresh air into the cabin. That's one of the reasons why airplanes get cold. And you also, if you're sharing an airplane with 300 people, you constantly have to have some fresh oxygen so that you don't just all die of carbon dioxide poisoning. So fresh air is coming in, but the it is a pressurized cabin, and they keep that change about 8 pounds per square inch. So in order to make the math easy, let's say that this was a 50 caliber bullet that shot through the airplane. Why 50 caliber? Well, if something's 50 caliber, that means it's 50 1/100ths of an inch in diameter. So the area of my bullet, and I'm going to make this square. I know bullets are not square, but I'm going to make it as easy as possible here, is 1/2 inch by 1/2 inch. So if I take 1/2 inch by 1/2 inch, the area of my hole is 0.25 inches squared. So what is the force, the suckage force, pulling things out of the aircraft cabin? Well, pressure is force divided by area. Force is going to be pressure times area. So the difference, that 8 pounds per square inch times the area of my hole, 0.25 inches squared, this is going to end up being 2 pounds of pressure. And if you're wondering if that's enough to suck things out of the airplane, no, it is not enough to suck things out of the airplane. A little duct tape would probably take care of that quite easily. It would not be a big deal. But if the hole got bigger, then it would be a challenge. So let's say that you've got one of these side windows blows out. And I'm guesstimating that the size of one of those windows is 12 inches by 12 inches. They don't seem that big when I'm in airplanes, but let's pretend. That would give them a surface area of 144 square inches. So if a window let go, what would be the force pulling things out of the aircraft due to pressure differentiation? Well, again, pressure times area, 8 pounds per square inch. And where did I get that 8? That's where they try and keep that pressure to maintain the difference between the inside and the outside. That's what they're doing up there in the cockpit, is regulating things like that. And that would give over 1,100 pounds of pressure going through that window. So now with a bigger hole, it becomes a bigger challenge. And by the way, Mythbusters did happen to get this one right, which I'm always pleased with. This is not a happy story, but I want to illustrate that there was some reality that occurred here. Back in the 1980s, there was a flight between different Hawaiian Islands and an Aloha airplane flight. A whole huge panel of that aircraft, 18 feet long, let loose. And the pressure exerted from the high pressure inside of the cabin to the low pressure of the air outside was big enough that one flight attendant, she was the only one that was not wearing a seatbelt. She happened to be standing in this section of the aircraft. She was ejected, fell into the sea, which her body was never recovered. Everybody else, some people were injured, but they were survivable injuries. Everybody who were wearing their seatbelts were okay. And Two things to say about that. Bigger the hole, the bigger force of ejection in a situation like this. And two, wow, the 737 landed safely with that big a hole in it. Impressive aircraft. All right, that will do for this one, and I'll see you next time.